Section 6.5 is on slope-point form of the equation of a line. So we've done the slope-intercept form, and it's called slope-intercept form because you can easily tell the slope, which is your m, and the y-intercept, which is your b, when it's written in that form. So slope-point form, you can easily tell the slope when it's written in that form, and the coordinates of a point, x1, y1, on the line. Or if you're given that information, you can come up with the equation by writing it in that form. The slope-point form of the equation actually comes from using your slope formula, difference in y coordinates over difference in x coordinates, but you kind of have to consider xy being like a general point that's on the line instead of like x2, y2. So if we use the point xy and a point x1, y1, the slope would be y minus y1 over x minus x1. And then if you consider that as m over 1 and cross multiply, you will get y minus y1 equals m outside of x minus x1, which is your slope-point form of the equation. So we look at this little investigation here now. It says find the slope of the line shown in the graph. So the slope of that line would be 1 minus 5 over 3 minus 1. If we just take the y coordinates, this y minus that y, and this x minus that x. So we end up with negative 4 over 2, which is negative 2. If we find the y-intercept of the line, we look at it's crossing over the y-axis at 7. And so the equation of the line from our last sections using slope-intercept form would just be y equals negative 2x plus 7. So now if we use the slope-point formula by taking the slope and substituting the coordinates of a point P on the line, we will get y minus 5 equals negative 2 outside of x minus the x coordinate of that point is 1. So then it says to solve your equation in D for y. So we'll just write it out again. Y minus 5 equals negative 2 outside of x minus 1. To solve that for y, we're going to have to expand here by distributive property and get y minus 5 equals negative 2x plus 2. And then if we get the y by itself by bringing the negative 5 over or adding 5 to both sides, you get y equals negative 2x plus 7. And if you compare that to the answer we got in C, it's the same as answer C. So we can tell that the equation written in slope-point form and the equation written in slope-intercept basically are the same thing. So if you tried the slope-point formula, suppose we had used point Q instead of point P, we would get y minus the y coordinate of that point is 1 equals slope would be negative 2 outside of x minus the x coordinate of a point on the line. And then if we rewrite that, this becomes negative 2x plus 6, and then this becomes negative 2x plus 6 plus 1, which again is the exact same equation in slope-intercept form. So all those forms of the equation represent the same line. They're equivalent forms of the equation. Look at the next question there. It says, based on your results above, how can you determine that these two point slope form equations below here represent the same line? So the easiest thing to do would be to change them both to the same form. So we're going to change both to slope-intercept form. Because when it's in that form, the line, there's only one slope and there's only one y-intercept. Slope point form, of course, you could use any point that's on line, so there'd be lots of different answers, even though they all represent the same line. And to show that, we can change them to slope-intercept form, because if they represent the same line, they should have the same slope-intercept form. So this one here would be y minus 3 equals 4x minus 4, if we distribute that 4. And then we've got y equals 4x minus 4 plus 3 when we bring the negative 3 over, or add 3 to both sides. And this is 4x minus 1. And this one here, if we distribute the 4, that gives you y plus 5 equals 4x plus 4, y equals 4x plus 4 minus 5, which gives you 4x minus 1. So these represent the same line. Okay. Use the slope point equation, y minus y1 equals m outside of x minus x1, to find the equation line with a slope of 3 and passing through the point 2, 1. So that would just be basically, if we use our formula again, we're just going to fill in the y corner of the point for y1, and we're going to fill in the slope, which we have to find first. So the slope, come over here, pick any two nice points on the line. So this point, the point that's given, and this point should be okay. And again, the x and y axis are labeled the same. Every block is 1 unit, so we can use the rise over run method. Up 1, 2, 3, and to the right 1. So the slope should be 3 over 1, or 3. So therefore 3 goes in for m, and then x minus the x coordinate of that point that we used was 2. So that's the point slope, a slope point form of the equation. Question 1. Determine the equation of each line graph below by identifying the slope and a point on the line. Write your answer in slope point form. So we're going to use the point that's given there, because if we don't, then we'll all have different answers. So again, because this formula depends on which point you use, you may not get the same answer as somebody else in the class if you didn't use the same point that they used. So we're going to use the one that's the coordinates are given right here. And the slope would be, we're going to use the rise over run method, because the x and y axes are labeled the same way. Every block is 1 unit, so that means from this point that's here, you're going up 2, and then to the left 3, so that would be a slope of negative 2 over 3. And the point we're using is 5, 4. So therefore our equation would be y minus the y coordinate of the point equals slope, which is negative 2/3, outside of x minus the x coordinate of that point. And again, we'll use the point negative 5, negative 1, slope. Slope would be we'll use the point here, next point, so that would be a rise of going down 1 and right 1, 2, 3, 4. So that would be slope of negative 1 over 4. And the point we're going to use is the point that's provided there, -5, -1. Now again, you don't have to have this point. You could use any one of the points, but we're just going to use that point there. That's the coordinates are already given. And then this would be y minus a -1 becomes +1 equals -1/4. X minus a -5 becomes +5. Question 2. To graph the equation line given in slope point form. So what we'd have to do here is pick out a point to start from the equation. We know that a point that's definitely on this line is the point that was used to create the equation, so that would be x minus 1 would mean 1 would be the y coordinate of a point that's on the line. And if it's y plus 5, that would mean -5 must have been the y coordinate of that point. And the slope is just this number right here in front of the x's, x stuff in brackets. So we want to plot the point 1, 5 and then count slope. Slope would be the same as 2 over 1, so we go up 1, right 2, or down 2, left 1. That would result in a positive slope of 2. And this one here, the point that we know is on this line would be, if it's x plus 6 in the equation, that means -6 must have been the x coordinate, and y minus 1 means 1 would be the y coordinate, and the slope can be read directly off the equation by looking at the number in front of the x side, and this would be -2/3. So we're going to plot -6, 1, and then count the slope. So down 2, right 3, down 2, right 3. If we go up 2, we can't really go left 3 unless we go off the grid, so that's good enough. Those points there we'll just draw. Okay. And the last question on this page asks you to write the equation of the line with the given slope and point. So that would just simply be substituting into your equation y minus y1 equals m slope outside of x minus x1. So in this case it would be y minus 1 equals slope outside of x minus a -2 becomes x plus 2. This one would be y minus a -3 would become y plus 3 equals slope outside of x minus 4. And the last one would be y minus 6 equals slope would be -2/3 outside of x minus 3. Okay, so number 4 asks you to identify the slope and the coordinates of a point from your equation. So if we look at this one, we know the slope is this number, so slope is 2, and the coordinates of the point would be x minus x1, so that would have to be 3, would be the x coordinate, and y minus y1 would mean that the y coordinate would have to be 1. B, the slope would be the number in front here, and the point would be, because it's x plus 7, that means the x coordinate must have been -7, because x minus a -7 would become x plus 7. And then y minus 3 means the y coordinate of the point had to be 3. The slope of the next one is the half, and 1 would be the x coordinate, but there's nothing added or subtracted to the y, so that would have to mean that the y coordinate was 0. And the slope for this one would be the number in front of the x, and the coordinates, there's nothing added or subtracted to x, so that means 0 must have been the x coordinate, and 4 would have been the y coordinate. Okay, question 5 asks you to write the following equations in slope-intercept form. So that means we're going to have to use the distributive property to get rid of the brackets and then isolate the y. So this is going to be y plus 1 equals 2x minus 10. And then just isolate your y by bringing that 1 over or subtracting 1 from both sides. So it's going to be negative 10 minus 1, which means you're going to get 2x minus 11. And this one you're going to have to distribute the half. It's going to give you y minus 3 equals a half x plus a half of 8 would be 4. And then you bring over your 3, so that becomes plus 3. And then you've got, put your like terms together, so that would be plus 7. And this one here, you're going to distribute the negative a third. And then negative a third times negative 6 is going to be plus 2. Because that will become positive 6 over 3, which is 2. And then that would be y equals negative a third x plus 2 minus 3. And if you, oops, I don't need a plus minus there, so just erase that. So that's going to give you plus 2 minus 3 is going to be minus 1. Question 6. Write an equation for the line that is that passes through the point 6, 4 and is parallel to the line 2/3 y equals 2/3 x plus 1. So if it's parallel to that line, it means the slope has to be 2/3 because parallel lines have the same slope. So, and the point is given as 6, 4, so that would be y minus 4 equals slope, would have to be 2/3 x minus 6. Second equation says that the point is negative 2, 5 and it's perpendicular. So perpendicular would mean that the slope of the given line slope of the given line is, this is in slope-intercept form, so this would be your slope, negative a half. So therefore, slope of a perpendicular line, I'll just use perpendicular, would equal the opposite reciprocal of that, which would be positive 2 over 1, or just positive 2. And therefore, the point we're given is negative 2, 5. So if we use our slope point form, that would be y minus the y coordinate of the point equals slope, which is 2 outside of x minus the x coordinate. X minus a negative 2 is going to be x plus 2. And there's your slope point form of the equation. And the last one asks you to find the equation line through these 2 points. Well, we need to find the slope first, because no matter what form of the equation we use, we need the slope. So the slope would be 2 minus 4 over, so 2 minus 4 and 8 minus 3, and that's going to give you negative 2 over 5. And it doesn't state what form of the equation to write it in, so the easiest one to use is just slope point form, so we can pick either one of those 2 points So we're going to pick A. So y minus 4 equals, slope would be negative 2/5. Outside of x minus the x coordinate of that point would be x minus 3. Okay, question 8. Students from Halifax are planning a ski trip to Corner Brook. If 20 students go on the trip, it will cost $1,200 per person. If 50 students go, the cost will drop to $900 per person due to a discount. So you've got a relationship there between cost and the number of students who are going on the trip. So based on that description, the cost would be the dependent variable, and the number of students would be the independent variable. So based on that, we know that our ordered pairs should have the independent variable first, which would be, for the first one, there was 20 students going at a cost of $1,200, and the other ordered pair would be 50 students at a cost of $900. So if we calculate the rate of change, that would be the slope, and that would be 900 minus 1,200 over 50 minus 20, which would be negative 300, sorry, over 30, which would be negative 10. And that would, now the dependent variables are dollars and the independent variables are people, and even though we have negative dollars in this sense, it means that the price will drop by $10 per student. So for every student extra that goes, the price decreases by $10. So to take that information now and write the resulting equation in slope point form, we can pick either one of the two given points that we found in A. So I'm going to pick the first one, and then my equation would be y minus 1,200 equals, the slope was negative